Welcome to Docker Fundamentals. This is part 2 of our 3-course e-learning series designed to get you up to speed on the main functions of Docker. In this course, we will be exploring the core of the Docker platform that will allow you to develop your applications inside Docker containers. My name is Johnny, and I've been running training courses on lots of different software products for over 5 years. So I started by training on products from Atlassian. So you may have heard of products such as Confluence and Jira. I ran training courses online for those and on site. And then I wrote the courses for Bamboo, which is a continuous integration server. I wrote the course for Stash, which is a product to manage Git repositories. I've run training on the Zendesk platform, on Good Data, and more recently I developed the training courses for Nginx. First, a little bit of housekeeping. So this course runs for 1 hour, including exercise time. And because we have those exercises for you guys, you're going to need a Linux machine. Now, if you are on a PC or a Mac, you can install a virtual instance of Linux, preferably Ubuntu, because the demonstrations that I'll be performing during the session are going to be done on Ubuntu. So if you use Ubuntu, you'll be able to follow me exactly. So you can have a Linux machine on your own PC or Mac, or you can use a cloud provider such as Amazon or DigitalOcean, and make sure you're familiar with the Linux command line. You also should have taken the Introduction to Docker course, which is the first course of this e-learning series. So I did say that this was the second course in our series. If you are new to Docker and you haven't seen the first course, Intro to Docker, I highly recommend that you go through that course before taking this one. In that course, you will learn about container-based virtualization, the Docker concepts and terms, and some simple commands that we'll be using a lot in this course. Right, what's in store in this course? We'll start by learning how to build our images, and there's 2 ways we can do that. We can commit the changes we make in a container, or we can write a Docker file. We'll look more into managing our images and containers and how to upload our images to Docker Hub. Then we'll look at mounting volumes in our images and some basic container networking and how we can integrate Docker into your continuous integration process. Okay, so the first main topic in this course is going to be building our images. And in this section, we're focusing on building the image by committing the changes we make in a container. A Docker image is made up of file systems layered over each other. You can see on the diagram how each image consists of multiple layers, and each layer is just another image. The image that is below is referred to as the parent image. And the image at the very bottom of the stack is the base image or the base layer. So that diagram there, the base layer is a Debian image. Now all these file systems are mounted as read-only. So how do we make changes in a container that is launched from an image? Well, when you launch a container from the image, Docker adds a writable layer, in other words, a read-write file system on top of all the other layers. The process that we tell the container to run will run on this read-write layer, and any changes that you make occur on this layer as well. Now hold on, all the other layers are read-only. So say for example, we have the Debian image from the diagram, and I want to change a file in Apache. So you can see the Apache layer there just below the writable layer. So that file is read-only in the Apache layer. What happens is Docker uses a copy on write system, where the file from the read-only layer gets copied into our writable layer. The original read-only version is still present, but is now hidden. And the changes happen on that writable layer. So this copy on write system is what makes it so fast to spin up containers. Okay, so we have a new command to learn, and that is docker commit. This command saves the changes you make in a container as a new image. When we run the command, we specify which container we are committing, and we need to specify the image repository and tag. Now, if you don't specify a tag, Docker uses the default tag, which is latest. The naming convention I like to use when specifying a repository is basically to use the same name as your application and prefix it with your username for the registry you want to distribute the image to later on. Now, that could be Docker Hub, or it could be your own private registry. So let's take a look at a demonstration of this. So in my terminal, I will type in docker run-it. We want to get a terminal in this container. So I'm going to use the Ubuntu 14.04 image and run the bash process or command. Inside the container, let's try using curl 127001, and notice how we don't have that program. So let's install it. apt-get install -y curl. So we'll wait for this to finish installing, and what I'm going to demonstrate here is we add a program to our container, and then we're going to commit this as an image. So once it finishes installing, which should be very soon, I will exit the container, and that's going to shut it down as well. Now if I run docker ps-a, we can find our container on that list. Let's grab the container ID, and then I'm going to run docker commit, put the container ID in there, and specify my username, Johnny2/myapp 1.0 as the tag, and that commits the container as an image. If I now run docker images, what you'll see is the new image. So you can see the repository, Johnny2/myapp, tag of 1.0, and the image ID. Now it's your turn to try this out. So go through the steps on this exercise and build a new image. You'll be doing exactly what I've just done on the demonstration. So pause the video here, take a few minutes to get familiar with your commands, and build your image.